Yeah, good evening, my dear students. To discuss DC machines for a gate point of view. See here, first types of DC machine, types of DC generators. So here, types of DC generator based on methods of excitation. Here we are going to be classified two types of generators. Two types of generators based on methods of excitation. Here, self excitation and separately excitation means. Here, based on methods of excitation, excitation is nothing but input to the generators. So here, self-excitation means the generator itself is going to be given as an input for the generator. Those generators are nothing but self-excited, separately excited generators. Means here the field winding is excited by separate source, separate DC source. Such a types of generators we can call as a separately excited generators. So here there will be two basic differences for this separately excited and self-excited generators. In self-excited generators, there is no separate DC supply for the field winding. So the armature itself is going to be provided as a supply to the field winding. Then it is nothing but self-excited generator. While coming into separately excited, the field winding is separated from its armature winding. That field winding is excited by separate DC source, then it is called as a separately excited DC generators. So here basically the armature winding and field winding, there are two types of windings in main basics, basic types in DC generators. Generally there is in a stator, there is a rotor. The rotor will be represented by armature and the stator will be stator winding is represented by field winding. For that armature winding, that is rotor will be represented in A1 and A2, and field winding is represented, stator field winding represented by F1 and F2. So here self-excited generators, again there are three types of generators: shunt generator, series generator and compound generator. Shunt generator, series generator and compound generator. So simply here we can see that separately excited, this separated field winding connected with respect to armature in parallel, then it is called as a shunt generator. Here, the field winding is connected in series with armature winding. That generator is nothing but a series generator. Here, the field winding is connected parallel and as well as series. Such types of generator we can call as a compound generator. In compound generator, there are two types of generator: long shunt compound generator and short shunt compound generator. So what is the basic differences between long shunt compound generator and short shunt compound generator? In long shunt compound generator, the shunt field winding connected the combination of armature winding and series field winding. Because of this, there will be some long for the shunt field winding. Then it is called as a long shunt compound generator. While coming into short shunt compound generator, the name itself is having short, means only the shunt field winding, the parallel winding is connected in series in parallel with only armature winding. The shunt field winding connected in parallel with only armature winding. Then it is called as a short shunt compound generator. These are the basic types of generators we are going to be studied in DC generators. So here there will be some separate applications for this shunt generator. There will be, it is in a constant, it acts as a constant voltage source. Series generator, it is going to be as it acts as a booster. Some applications here compound generator, combination of shunt and series here. So like that, based on different types of applications, we are going to be categorized shunt, series, compound generator. But coming into separately excited generator, the generator characteristics are similar to that of shunt generator. But here, there will be a separate source is required. There is a drawback for the separately excited generator, DC generator. So this is regarding types of generators. See here. So there is a One more important questions for this. Some more important questions for this gate point of view in shunt generator. Generally, what is the no load voltage of shunt generator? What is the no load voltage of series generator? What is the no load voltage of compound generator? So like that, they are going to be asked some questions here. So here you can see the basic diagram here. It is a series generator, and shunt generator and compound generators. The no load voltage of shunt generator is the rated voltage. That is nothing but 220 volts. So generally, because of residual flux, there will be a small voltage produced across the armature terminals, that is A1 and A2. So because of the shunt field path we are providing, this small voltage drive current through the shunt field winding. Then there will be a small flux is developed in the shunt field winding. Because of this increase of shunt field flux, the generated voltage increases. Again, this increased generated voltage drive current through the shunt field winding. Like that, there will be increases the shunt field flux because of the shunt field path. Then increase of field flux increases generated voltage. This process is cumulative until the generator build up rated voltage across its armature terminals. While coming into series generator, so due to residual flux, there will be a small voltage build up across its armature terminals, that is A1 and A2. So there is no closed path for this series field winding. There is no closed path. So that's why the voltage build up across its armature terminals A1 A2 is residual voltage. So because of this, we can say that the no load voltage of series generator is 2 to 5% of its rated voltage. So that is nothing but 2 volts to 6 volts in 220 rated voltage generator. While coming into shunt generator, what is the no load voltage of shunt generator? The no load voltage of shunt generator is rated voltage. So that is a basic important question for gate point of view, shunt generator and series generator. While coming into compound generators, the no load voltage of compound generators are nothing but again it is act as in shunt. There is a shunt field path for the long shunt, either maybe short shunt. So for that reason here, the no load voltage of compound generators also rated voltages. So see here, the no load voltage of series generator is 2 to 10% of its rated voltage. The no load voltage of shunt generator is rated voltage. The no load voltage of compound generator is also rated voltage. So voltage build up in DC shunt generator. It is one more important topic for a gate point of view here. See here, the field winding is connected in parallel with armature winding. Then it is called as a shunt generator. The voltage build up in DC shunt generator. That is nothing but the voltage build up process in self-excited generator. The voltage build up process in self-excited generators. So see here in armature terminals across A dash or A1, A2, because of residual flux. So actually what is meant by the residual flux? The number of times we are going to be excited the field winding, due to retentivity property, there will be flux established in the field winding. Because of this flux, there will be a small voltage build up across the armature terminals. That voltage is nothing but residual voltage. So here when the generator is runs rated speed, so because of this retentivity property, there is a residual magnetism established in the field winding. Because of this residual magnetism, there will be a small flux, 2 to 10% of rated flux established in the shunt field winding. Because of this flux, when the generator runs at rated speed, there will be a small voltage build up across AA terminals, armature terminals. So when here switch S is closed, then switch S is closed here. When switch S is closed, this residual voltage drive current through the shunt field winding. When the current flow in the field winding here from the graph you have to see increases from origin to OD current. When OD current increases, So the generated voltage increases to from point J. Then automatically, because of this increment of generated voltage J, again the field current flows in the shunt field winding increases from OD to DH. Then the generated voltage is increases L. So then again this increased generated voltage drive current through the shunt field winding. Then automatically the current flowing through the field winding is increases from DH to HK. This process is cumulative. The generator will build up rated voltage across its armature terminals. So when it reaches to rated voltage, the shunt field flux increases can be stopped because of saturation in the shunt field folds. Then automatically the generated voltage is going to be constant. So this is the process takes place in voltage buildup in DC shunt generator. So what are the there will be some main conditions are required to build up the it will be take voltage build-up process in the DC shunt generators. There is very important 4 points. One is there must be some residual magnetism in the generator poles, and field windings and armature winding should be correctly connected. The field winding and armature winding should be properly connected. The resistance of field winding should be less than the critical field resistance. So see here the resistance of the field winding means here the field winding is also having some resistance here. Here what is the critical field resistance? Critical field resistance means what is meant by the critical field resistance? When the resistance is more than the critical field resistance, the generators will fails to build up the voltage. Means here there will be more resistance in the shunt field winding. Because of this more resistance, more than the critical field resistance, the residual voltage it is not possible to drive current through the shunt field winding. That's why always when we are going to be design the shunt field winding, the shunt field winding resistance must be less than the critical field resistance. When it is less than the critical field resistance means, so here whatever may be the residual voltage build up in the armature terminals, that voltage must drive current through the shunt field winding. When this generated voltage, residual voltage, drive current through the shunt field winding, automatically the shunt field flux is increases, then generated voltage increases. This will again drive current through the shunt field winding. Again, the current flow in the shunt field winding is increases. Like this process is cumulative. The generator build up rated voltage across its armature terminals. So this is the very important point to helps to build up the voltage in DC shunt generators or self-excited generators. So for that reason, it must be required the resistance of the field winding should be less than the critical field resistance. Here you need to understand one point, the critical field resistance. What is meant by the critical field resistance means the total field circuit resistance must be less than the critical field resistance. So means when it is more than the critical field resistance means the residual voltage will not drive current through the shunt field winding, then there is no buildup of voltage process. So that is the point, third point. Next, coming into fourth one, very important one. The speed of the generator greater than the critical speed. The speed of the generator greater than the critical speed. So actually what is meant by the critical speed in the sense? Here critical speed means already we know that the generated voltage directly proportional to the flux and speed. So here we are going to be established rated flux, but the speed of the generator is zero. The generated voltage also zero. So when we increase the generated voltage, then we can increase the speed of the generator from zero onwards. When reaches its some point automatically, the generated voltage starts build up the voltage. Means Suppose if the generate critical speed is 800 rpm, the rated speed of the generator is 1500 rpm. If the critical speed of the generator is 800 rpm, now if the generator we are going to run below the critical speed, that is nothing but 800 below speed, the generators will fail to build up the voltage. Definitely, if you want to produce the build-up process, voltage build-up process in the DC shunt generator, definitely we are going to make to possible the generator speed is more than the critical speed, that is nothing but 800 rpm. Once the generator runs 800 rpm onwards, it increases more than 800 rpm or 800 rpm, then the generator will build up the voltage. If the generator run below 800 rpm, it fails to build up the voltage. Means here what is the conditions required to build up the voltage in DC shunt generator? Means there must be residual flux is required in magnetic poles, that is generator poles, and the field winding and armature windings are properly connected. The resistance of the shunt field winding or field winding must be less than the critical field resistance. The speed of the generator is greater than the critical speed. Here critical speed means at particular speed generator starts build upping. Below that speed the generator fails to build up. Above that speed the generator will build up the voltage. So that is point here we are having to learn critical speed and critical field. These are the very very important 2 points in build up of process: critical field resistance and critical speed. So these are the conditions to build up the voltage. Suppose sometimes they are going to be asking the questions. So what are the conditions fails to build up the voltage? What are the conditions fails to build up the voltage means automatically. These are the 4 conditions again we are going to be important. So for that, if generator fails to build up means there is a chance there is no residual magnetism. There is a chance the field poles are the shunt field winding and armature windings are not properly connected. Causes for failure of buildup of voltage in DC shunt generator means there is no residual flux. Simply the shunt field winding and armature winding is not properly connected, and also here the resistance of the field winding should be more than the critical field resistance. If it build up means less than the critical field resistance. If fails to build up means the critical field resistance is the shunt field resistance is more than the critical field resistance. So next coming into critical speed, if generator fails to build up means definitely we are going to say that the generator speed is below the critical speed, then the generator fails to build up. So these are the 4 conditions are very very important for the generators build up process or generators fails to build up the voltage process. Yes, my dear students, any doubts regarding this? Next here, which of the following generator will have the two critical resistances? Here there is a question. So see here, which of the following generator will have two critical resistances? Already we have discussed previously critical field resistance. Critical field resistance means if it is in a shunt generator, only shunt field winding will be there. So for that, there will be one critical field resistance. If series generator, only series field winding is there. For that, only one critical field resistance is there. So your question is, which of the following generator will have two critical resistance? Shunt generator, series generator, compound generator. D, none. Means here, which one is the answer is compound generator. Why? Because for compound generator, there is a shunt field resistance. There is a series field resistance. For that, definitely here we are going to be find out two critical field resistance. For that, here we can say that answer is compound generator. Next, see, these are the very, very important previous gate questions. See the first question one. A DC shunt generator build up its rated voltage. If the direction of rotation is reversed by keeping the field connection is same, then the generator will. Here, a DC shunt generator build up its rated voltage. If the direction of the rotation is reversed by keeping the field connection is same, then the generator will. Actually, if the generator is going to be build up its rated voltage up to its rated voltage, means the generator is going to be runs in clockwise direction. The residual voltage drive current through the shunt field winding. Because of this, the shunt field flux is going to be added with residual flux. Then resultant flux is going to be increases. The generated voltage also increases. But here, instead of direction is we are going to be changes. Instead of here, if the direction of rotation is reversed by keeping field connection is same, only here rotation of the generator is going to be changes to opposite direction. Opposite direction means the residual flux build up in the armature winding is opposite to the shunt field winding. Then the resultant flux is going to be decreases. Then there will be no buildup of voltage takes place in the armature terminals. So that's why here option is C is the right option. So means build up its rated voltage with same polarity. B, build up its rated voltage with reverse polarity. No build up of voltage. D, none. Means what I am saying, suppose the speed of the generator is clockwise direction. The field polarity is properly connected to armature winding. Whatever may be the residual voltage build up across armature terminals, AA, this residual voltage drive current through the shunt field winding, then shunt field flux is going to be starts increasing from 0 onwards. Now this increased shunt field flux is going to be added with residual flux. Then resultant flux is increases, the generated voltage is increases. This increased generator voltage again drive current through the shunt field winding. The shunt field flux further increases, further increment of the shunt field flux again added to residual flux. Like this process is cumulative until the generator is build up rated voltage. But here, gate question is, a DC shunt generator build up its rated voltage. If direction of rotation is reversed by keeping the field connection is same, the generator will A, build up its rated voltage with same polarity, build up its rated voltage with reverse polarity. C, no build up of voltage. So means here armature terminals are the rotation of the rotor is opposite, means the residual flux is opposite direction to the shunt field flux. Because of this, the flux in the machine will reduces to 0. Then no buildup of voltage takes place in DC shunt generator. Now see the one more question. A DC shunt generator build up its rated voltage if the direction of rotation and field connections are reversed, the generator will. Previously only rotation is changed. Now here in this question, a DC shunt generator build up its rated voltage if the direction of rotation and field connections are reversed, the generator will A, build up its rated voltage with the same polarity, build up its rated voltage with the reverse polarity, no build up of voltage, none. So means here speed is reversed and shunt field terminals also reversed. Because of this reversed residual flux, the shunt field flux also reversed, means automatically both are in negative direction, but both are added together, then the buildup of voltage is also increase in reverse polarity direction. That's why option B is the right option. Build up its rated voltage with reverse polarity. Next, see one more question. A DC shunt generator build up its rated voltage if residual magnetism and direction of rotations are reversed. Then the generator will. Here, DC shunt generator build up its rated voltage, but residual magnetism and direction of rotations are reversed. Then the generator will. But here they cannot change the shunt field connection. Because of this, again, the residual flux is opposite to shunt field flux. So the flux is coming into nearer to zero. Then there is no buildup of voltage takes place. In this case also. Means here also option is, right option is, there is no buildup of voltage. So these are the important questions for the buildup of voltage in shunt generator. Next, coming into armature reaction. The important one more topic, armature reaction. So armature, what is meant by the armature reaction means the effect of armature flux on main field flux is called as an armature reaction. The effect of armature flux on main field flux is called as an armature reaction. See here, when this armature reaction is existence in the sense, suppose there is no load means there is no current flowing through the load means automatically there is no armature current. The armature flux is zero. There is no armature reaction. So when actually this armature reaction is existence in the sense, when load is connected, the rated voltage buildup across its armature terminals will drive current through the load. That same current will flow in the armature winding. Then there will be a creation of armature flux in the armature winding. This flux is going to be effect for the main field flux. This reaction we can call as an armature reaction. Actually, the generated voltage is directly proportional to flux and speed. The speed of the generator is always we are going to run at rated speed. That is maximum possible speed. Because of this maximum possible speed, the generator will build up the rated voltage. The generator will build up the rated voltage. Now coming into flux, when flux is reduces, the generator voltage is going to be reduces. When flux is increases, the generator voltage is increased. Eg is directly proportional to flux. That is main field flux, useful flux, our required flux. That flux is nothing but seen here from north pole to south pole existence flux. Suppose when armature is not carrying the current, so whatever may be the mention here, crosses and dots, there is no currents flowing in the cross and dot. For that, there is no armature flux. When load is connected, there will be armature flux is created. This armature flux is crosses the main field flux. See here, horizontal axis, vertical axis. In vertical axis, some amount of armature flux is crosses the main field flux, such that we can say that there is a cross magnetization existence. When some amount of flux is going to be opposite to the main field flux, that is nothing but demagnetization effect. Generally here, because of armature reaction, there is a cross magnetization effect, there is a demagnetization effect. There are two important cases in this case, armature reaction. What are those two important cases means? Because of this armature reaction, there will be existence of cross magnetization effect. There is a existence of demagnetization effect. When cross magnetization is going to be existence automatically, the main field flux is going to be distortional. The generated voltage is also distortional. So such that we are going to be reduces this cross magnetization effect to improve the generated voltage. And also demagnetization effect. The main field flux is going to be reduces. When the main field flux is going to be reduces, because of this armature reaction, the generated voltage is going to be reduces. So for this, we can say that because of this demagnetization effect, there will be a reduction in the generated voltage. There is a reduction in the generated voltage. So means actually what is the reason we are going to be design the generator to build up the voltage? When load is connected automatically because of this armature reaction, the generator voltage is going to be reduces because of the armature flux is going to be opposite to the main field flux. So definitely here we are going to be reduces this demagnetization effect by taking some methods also. That is also very, very important. See here, uh, actually when the arm here see the crosses and dots, because of this crosses, there is a armature flux. That flux is going to be armature flux crosses the main field flux. That is nothing but cross magnetization effect. So under tailing pole tip, this armature flux is going to be same direction with the main field flux. Total flux is going to be increasing. There is a strengthening effect. Under leading pole tip, the main field flux is going to be opposite to the armature flux. Because of this opposite direction, there will be a weakening effect. Similarly, in downwards, leading pole tip and tailing pole tip means there is a strengthening effect under trailing pole tip. There is a weakening effect under leading pole tip. So always the strengthening effect equals to weakening effect. There is no demagnetization effect. This is a very, very important question for the gate point of view. The strengthening effect is always less than the weakening effect. Because of this, there will be a demagnetization effect is existent in the disease missions. So why this strengthening effect is always less than the weakening effect means because of due to saturation of tailing pole tips. Here actually there will be strengthening effect is takes place because of saturation of tailing pole tips. The strengthening effect is not equal to the weakening effect, but weakening effect is going to be the strengthening effect is less than the weakening effect. Because of this less strengthening effect, there is a reduction in main field flux. That is nothing but there is a demagnetization effect. So in generator, where it will be takes demagnetization effect in the sense at tailing pole tip. While coming into motors, so for that motors opposite direction rotation, for that where will be the strengthening effect is takes place in the things leading pole tip. It's very, very important question. See here, and also there will be some questions for GNA and MNA axis. Actually, what is meant by the GNA axis? GNA axis, geometrically neutral axis. MNA axis, magnetically neutral axis. Means here, geometrically neutral axis is going to be perpendicular to the poles. So when once these both are coincide, GNA coincide with MNA, there is no load. When load is increases, load current increases, armature flux is increases. Because of this, there will be a cross magnetization effect and demagnetization effect. Because of this, the MNA will shift from GNA. Based on load we connect, the MNA will be shifted from GNA. So this is the main important questions for the armature reaction for a gate point of view. So where will be the takes place demagnetization effect in generator and as well as motor. In generator, tailing pole tip, and motor, leading pole tip. Actually, what is the cause for demagnetization effect means generally the strengthening effect is always equal to the weakening effect. But because of saturation of tailing pole tips, the strengthening effect is always less than the weakening effect. For this, for this reason, we can say that there will be demagnetization effect in the armature reaction. See here, there will be some angle theta. The MNA, magnetically neutral axis, is shifted from GNA. Actually, what is meant by the MNA axis means this axis is perpendicular to the main field flux. Main field flux. GNA is nothing but geometrically neutral axis. This axis is perpendicular to the main field poles. So these are the two axes, MNA and GNA, very, very important. See here, effect of armature reaction, cross magnetization effect, that is nothing but distortion of air gap flux. So what is the main thing happening when cross magnetization effect means sparking at the brushes, very, very important. Demagnetization effect, that is nothing but reduction of net flux, main field flux. In a generator, generator voltage and terminal voltage will decrease. In motor, speed increases and torque decreases. Very, very important. The MNA shift in the direction of generator rotation proportional to the load. When this, because of iron loss also increases, the commutation is also poor, failure of mica insulation. There will be some drawbacks, effect of cross magnetization. What are those drawbacks in the sense? Iron losses increases, commutation is poor, failure of mica insulation. So remedies for cross magnetization of armature reaction. That is nothing but by using high reluctance pole tips, by using choppering silent pole tips, by using compensating winding, by using interpolar winding. So this both compensating winding and interpolar windings are connected in series with the armature winding. That is very, very important question in gate point of view. There is a question, how we connect the compensating winding and the interpolar winding with respect to armature. Both are connected in series. The compensating winding is connected in series with the interpolar winding. This interpolar winding again connected in series with the armature winding. So by using high reluctance poles at pole tips, there will be less fluxes flows. Then it will be reduces the cross magnetization effect. So choppering poles means here we are going to increase the air gap. Because of increasing air gap, there will be reduction in cross magnetization effect. So these are the four important points. Remedies for the cross magnetization effect of armature reaction. One is by using high reluctance pole tips, by using choppering silent pole tips, by using compensating winding, by using interpolar winding. Yes. Now coming into commutation processing DC mission. This one also very, very important. There are some types of commutations, linear commutation, under commutation, over commutation actually. So what is meant by the actually commutation means here, the reversal of current flows in the armature winding, the reversal of current flows in the armature winding through the brushes is nothing but commutation process. When current reversal takes place within the time, that is nothing but linear commutation. The current reversal takes place more time, then it is nothing but over commutation. The current reversal takes place less time, that is nothing but under commutation. So for this here we are going to be taken three types: linear commutation, under commutation, and over commutation. So generally there will be under commutation takes place. So suppose if the current reversal takes place within the armature to the brushes means 2 seconds is required, means it will take only 2 seconds, means that is nothing but linear commutation. So it will take more than 2 seconds, that is nothing but under commutation. If time required is less, that is nothing but over commutation. Because of this commutation causes for delayed commutation. Actually it take 2 seconds means more than 2 seconds, that is nothing but under commutation. So what are the causes for delayed commutation? Reactance voltage and cross magnetization effect of armature reaction. Reactance voltage and cross magnetization effect of armature reaction. Actually what is meant by the reactance voltage means when current reversal takes place within this commutation here. So here you have to see the brush 1 is completely contact with segment 1. So for that here the current reversal takes place within the armature winding in the brushes means through the brushes means automatically when brush is contact with here full contact with segment A, there will be a current flow in the X and Y cases. Similarly, if brush is completely contact with segment A and B, now we can observe the current flow in the X and Y. Similarly, if the brush is completely contact with the segment B, how will the current flow in the coil? There will be a current reversal takes place in the armature coil within a time, that is nothing but linear commutation. If it will take more time, that is nothing but under commutation or a delayed commutation. So because of this change in current flow in the coil, there will be some voltage will be developed, self-induced EMF will be developed in the coil. This voltage will be opposite to the current reversal in the coil, that is nothing but reactance. Because of reactance voltage build up in the armature coil, there will be some delayed commutation. And also cross magnetization effect. Once this cross magnetization effect, some amount of flux is there in the brushes. Because of this flux, there will be some voltage will build up in the brushes. This voltage will opposes to the current reversal in the armature coil. So because of these two things, there will be delayed commutation. See here, causes for delayed reactance voltage. What is meant by the reactance voltage means when the current reversal takes place in the coil, because of this reverse current flows in the coil, sometimes positive, sometimes negative, then there will be self-induced voltage will build up in the reactance, that coil, armature coil. This voltage will opposes to the current reversal in the coil. That is nothing but delayed commutation. Cross magnetization. What is meant by the cross magnetization means because of this cross magnetization, some amount of flux is going to be established in between the brush and armature winding. Because of this, some voltage will be built up in the brush. This voltage will opposes to the current reversal in the coil. Because of this, we can say that there will be reactance voltage and cross magnetization effect causes for the delayed commutation. What are the methods to improve the commutation? One is resistance commutation, another one is voltage commutation. So because of this voltage commutation, we can neutralize the cross magnetization effect. Because of this resistance commutation, we are going to be reduces the reactance voltage drop, reactance voltage buildup. Then we can improve the commutation process. So these are the very important questions regarding gate point of view. What are the causes for delayed commutation? How we are going to be improve the commutation process. So what are the methods to improve the commutation process? Means resistance commutation and voltage commutation. That voltage commutation we can call it as one more interpolar commutation. Yes. Yeah. Uh, Thank you, my dear student, those who are actively participated in this session. Thank you. Next class we can see in DC motors.